While troubleshooting BGP flapping peer issues, the first and most important thing to look for is under which states the BGP connections are flapping, or under which states those states are staying stagnant. So say for the BGP connection is actually staying in active state, or it's flapping between active and idle state, or idle and established state. Each of those means something. But before we jump onto that, let's first take a look at the BGP finite state machine. The BGP finite state machine begins with the idle state. In the idle state, it's actually waiting for the start event, wherein you have configured the BGP peer configuration and you're now trying to establish a TCP connection. It's then that it not only tries to establish a connection with the remote peer, but it also listens for any incoming TCP connections. This helps to ensure that if either side is trying to establish a TCP connection, they are ready to listen, or they are even ready to form a session or initiate a session from their end. After the idle state, it moves to the connect state. In the connect state, BGP tries to establish TCP connection and tries forming or completing a three-way handshake. Once the three-way handshake process is completed between both the peering devices and it's successful, it moves to the open send state where it sends an open message. If three-way handshake is not successful, the BGP actually resets the connect retry timer and moves to the active state. In the active state, it again tries to establish the TCP connection. And if the three-way handshake is successful, it then moves to the open send state. In the open send state, while it has sent the BGP open message to the peer, the other side is expecting and trying to verify if the BGP information that received in the open message is correct or not. The information received as part of the BGP open message is the BGP version number, which has to match on both sides. The source IP, the source peering IP in fact, it has to be correct of what is configured on the remote end. Autonomous system number, ensuring that it's the correct autonomous system number either for IBGP or for eBGP peering. It has to match, and few of the fields. Once this information has been exchanged, if the remote peer confirms there's no error in the open message, it sends a confirm message that, okay, the open message is correct, and now we'll try to exchange the keep alive message, and then moves to the open confirm state. If for some reason there is an error with the open message, the peer sends a notification back to the sender and says that this is the problem that I have noticed with the open message that you have sent, and moves the connection back to the idle state, and the whole process starts again. But there's more to it. If you look at the finite state machine, you will notice that the step 3 and step 4 have the arrows back and forth. What that means is, while it is waiting for confirmation of the update message, if the TCP connection times out, it moves the connection back to the active state, and the whole process starts again. If the TCP connection doesn't time out and the information is exchanged, it moves to open confirm and exchange keep alives. If the keep alive message has been received and successful, it also exchanges the whole timer values between the two peers. And once that is done, it moves to the established state. In the established state, it's when the TCP and both the BGP connections are established and they're ready to exchange routing updates between each other. Now let's look at what different states mean when troubleshooting flapping peers. If the connection is stuck in idle state, that means there is no route or connected route to the peer. If you do a show IP route to that remote end IP, you might not even see that route present in the routing table. Or the remote inside of the link is in down state or is not configured. Either of those things. If the connection is staying in active state, that means there's no route to the peer address, or there's a configuration error with the update source. Means you're not specifying the correct source interface with which you're trying to peer with the remote peering device. If the states are flapping between idle and active state, it means that the TCP has established, but the BGP negotiations are failing. It could most likely be because of a misconfigured AS number value. If the connections are actually flapping between the idle and established state, that means it goes to the established state. When it's trying to exchange the routes, the BGP connection flaps and goes back to the idle state. In that situation, it would mean it is related to MSS value. MSS means the maximum segment size. We'll revisit that when we are discussing path MTU discovery later in this lesson.